it's not a true one. It's just a
Oh, what?
I just the heck this is like you're responding obviously know what's wrong.
Okay, so if you do open, what do you see? You see the molecule which you don't see any changes. It is the same as you had. And now you have the button results, where you can click on summary. So if you are not a Linuxoid, but we are already, you just look on this summary panel, and where should you look? What is the only number that you can trust, and the only, or not trust, the only number that algorithm is designed to generate? Yes. So you record this energy, and I will try my best to design a homework where you will need to go over several models and record energies. So, in a very narrow sense, we are done. if you, for example, if you have isomers of the molecule with the same stoichiometry and different stereometry, you prepare, you do this, and find where energy is lower, and tell if energy is lower, it is more stable and most likely appears in experiment.
Okay, so like if it's a cis trans and the cis is lower energy, you will see more cis.
Yes, yes, yes. Formally, Hartree-Fock theory is a theory for ground state. So there is a promise from designers of the theory, from Hartree and Fock, to generate only this number. Anything else that is fabricated in theory are auxiliary quantities, which are, by good luck, do have a little some correlation with real life. But it is only our frivolous interpretation of the result. That, so from the only reliable number is total energy. The rest is less reliable. But we will do it because it helps to assess properties of molecules and materials really well. Some of you who will select the charge analysis may also click on, in addition, in results, in addition to this summary, there will be Millikan charge distribution, seeing how the charge being withdrawn from reducing groups to oxidizing groups in numbers. So, any questions about this? So now you can, from now on, you can assess chemical stability of any molecule. The lower the energy, the better is stability. Just draw molecule, run single point, and see if energy is low enough. That's it. So for those of you who read in syllabus promised to assess chemical stability, you are done. Your goal is fulfilled, yes?
So I see at the bottom of yours says point group and it's S4, while bottom ours are point group C1.
It will be another subject too on the presentations. I'm not sure if you have time to touch it in the labs, but it needs to be touched in the presentations. So if there are no questions about this, now we are going to the new world. Less reliable, but more interesting. Through a lot of time and hard work and intellectual concentration, we will have hands-on to the algorithm for Hartree-Fock. There are many concepts, new knowledge, and you will enjoy. Hartree-Fock is one of the brilliants in the crown of humankind. But when we go through, you will see the implementation of our goals that we declared in the lectures. So that separation of variables, building blocks. So the structure and construction of the wave function of the overall function, and this is eigenstate of multi-electron wave function for lowest available ground state eigenstate. Right? And it is a system of whatever count of electrons for this molecule. So the overall wave function is constructed according to this principle of Slater determinant, and the Slater determinant uses as building blocks not atomic orbitals, but molecular orbitals. So right now you do not need to memorize it. I will focus on it again and again, but there are several stages. So we need big wave function of all electrons. It is constructed as Slater determinant of molecular orbitals. And molecular orbitals are superposition of atomic orbitals. So it's 3 star building. Molecular orbitals itself are not promised to be useful, but they are. Just by our observation, maybe as experimentalists or experimental computational chemists, we just run the codes and see that shapes of orbitals really correlate with properties of materials. Although there were no promise, it is a good initial assessment, and we will get as much benefits as possible from this simplified approach. So the electrons in this molecule form molecular orbitals. What are molecular orbitals? I ask the best chemist.
They're the space that the electrons take up.
Yes, and this space doesn't coincide with positions of atoms and atomic orbitals. It is a superposition of several atomic orbitals, right? And those are like shapes in space. Yes, good. And there are several molecular orbitals, and one can fill them with electrons. Please raise your hand, or if you hesitate, just give me a secret sign if you never heard the term highest occupied molecular orbital. Everyone heard about it, right? So molecular orbitals can be unoccupied or unoccupied, right? There are several of those, and they are occupied by electrons, starting from lower up to highest occupied. And when we occupy all of them, we take only occupied orbitals, form Slater determinant, find total energy, and report the number that should come here. Number, come on. Okay, you saw it. Oh, okay, maybe it's overheated.
This is gonna explode. Yeah, it's like scary. It's a very loud happened in my history course. Okay.
Yeah,
You don't have
just
to
the middle lecture.
I was gonna say if it works, you need to
Well,
be
blue is better than red.
Yeah.
Although blinking is also kind of dangerous, like beep, 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 beep. Okay, so what we were talking about, the molecular orbitals. When we do Hartree-Fock calculation, they are generated. And all these concepts of connection between atomic orbitals, molecular orbitals, and overall wave function will be in class. But molecular orbitals are computed. Each of them has spatial distribution and energy. And some of them are lower in energy, some of them are higher in energy. And they are occupied by electrons. Good? To investigate the energies of orbitals, again, there is no promise that it is any observable, but there is a big correlation between energies of molecular orbitals and property of materials. So we are going to look into the output file and check what are the energies of these molecular orbitals. And later on, we will keep analyzing them. Good. It's me? No flashing. Okay. Good. And it is bright enough. I thought we need to turn the lights on to see something, but it's promising. So, I'm closing this computational chemistry for dummies and go into the file. So you look what is available, and you see this out file. If you're curious, you may have already looked inside and found that it is maybe too much information. Maybe not. But there are people who are so excited just to read inside this file, and they need nothing else. They need nothing else. So if you scroll it far enough, by the way, you'll see this total energy, right? And most interesting thing appears when you see the words OCC and VIRT. So what do they stand for? What is? Please find these records and guess what do they mean. Yeah, after this AAAA in brackets, there should be OCC.
Probably needs some honest work.
It's easier to do less names. You sort out interchange for
Did you put titanium?
Yeah.
So virtual means unoccupied. Virtual that they are fantasy, since this theory is not designed for excited states or unoccupied orbitals, so they are virtual auxiliary characteristics that just help us. Okay, so guess what is most interesting for any material when you jump from occupied to unoccupied, right? Band gap, right? So you see minus 0.5 something, and here the virtual minus 0.01. By the way, if orbitals are negative, it means it is energetically favorable for electron to stick there. If they are positive, it is a little suspicious. May explode. So, if your highest occupied is minus 0.5 and lowest unoccupied is about 0, minus 0.01, guess what are they, in which units are they expressed? Yes. So, atomic unit, what is the fraction between atomic unit and electron volt? Huh? 27. So, if your band gap, meaning the energy of set between highest unoccupied and lowest occupied is like 0.5 of atomic unit, how many electron volts? Yeah, 14, 13, so it's huge. If the Hartree-Fock theory is not the best today, 50, 70, 80 years ago it was perfect. Yes?
What's the each column? the degeneracies, or is that?
You
I mean,
mean
it's just like listing and then like the next row.
yes, yes.
Oh,
It goes this way.
okay.
Therefore, it is not very comfortable. But we will fight and win over this discomfort in 10 minutes. So, 13 electron volts. Believe me, it is not right for this material. But if it would be right, what does it mean about the color of material? Which range of electromagnetic radiation 13 electron volts belong? Huh? Not visible, yes, sufficient. So it will be white, transparent, right? Not absorbing visible light. Visible light coming through. If one does it experimentally with better theories, it will be much. It will be like 4 or 5 electron volts. But still, it will be invisible. So I do contrive a plan to design a homework requesting the value of band gap for set of materials from each of you. You have already built some atomic models in previous homework, so you can just go, run single point, and report the band gap values. Right? Do you like atomic units? Well, we need to accept them because if you do equations, you like atomic units. If you write codes, you like atomic units. But if you need to analyze properties, maybe they're not the best. Right? They're confusing and not common. Okay, so we may want to satisfy the request by Christian to go from mixed rows and column just to straight column. It would be much more logical to have energies arranged just along a column. And we will match the request of I don't know whom, whoever told that he or she doesn't like atomic units. So we will convert this list of orbital energies into electron volts and arrange them into the column. Please digest this plan, and I'll check what so that we all are on the same page.
Yeah, so which one is the variable gives me
did you try it all? So I just tried doing that other SSH configuration without cookies, and that didn't work either. But I noticed too on this one there was also like, so there was just basic X11 forwarding, and then there's like an LES, but then a little bit after that there was like X11 forwarding from 60 plus, and then that was no still. So do you think if you like, is there multiple systems that you have to change to the SSH?
I don't think so, because like
That should just be the general one.
right, if you use dash y, it doesn't matter if it's secure or not, because dash y really like trusted source, so it's not going to be as secure as dash x. So if you just change x11 forwarding to yes, that should report theoretically
badly.
yeah. Which means that that's not the problem.
Why?
Just because there's a few things that do that sort of thing. What was that program that you were running, Braden, that like gave you a bunch of quotes at the end? Like it just randomly pulled quotes for you? Oh, it was this one? Okay.
Every counseling job, no matter what you do, always give you a
Why was he usually Oscar Wilde?
mostly wide open.
It's at the bottom of the alpha file.
You'll be good at the correct termination. It's something to look forward to.
It's your piece of candy for making it through.
Right.
Wait, so I have no.
Yeah.
Maybe. It's worth a shot. Right. Is that what it
Maybe.
said? I said, yeah. Shows how I was talking about how a beaker blew up, but how one of the authors luckily measured the spectra before it blew up.
It's actually pretty deep flow velocity.
Yeah, I'm pretty sure mine has
Got one from J.D. Burnham.
That's really good.
The difficulty in science is often not so much how to make a discovery, but rather to know what to create.
Ooh.
So it is time for next wave of handouts, where some of the steps that we have completed will be recognizable.
Yes.
Everybody does research.
Oh, that's not good. Yeah.
I always pronounce it forward.
Skip couple of first
That's okay.
things
Right.
which are just heritage of previous years. So if you look to the slide number 4, it just shows what we did. You go to the summary after you open the result of your calculations, and there you do see the total energy. And then if you look through the out file, you are coming with a list of orbital energies in atomic units. The next step that we are going to do is a little script that is stored on this HPC computer. So Perl, what is Perl? We have experts in Perl. What is Perl? Huh? Okay, well, it's like platform independent. It will work anywhere, so it's like more between language and script, right? You don't need to compile. So there is a little Perl script that will fulfill the request of Christian. So it will read columns and read rows and write columns, and at the same time it will multiply by conversion factor and do a few other things. So here there is an empty spot between tilde, and here is an empty spot between name of the script and name of your out file. So type your out file, then put again empty spot and separated by empty spots 4 numbers, 4 keywords that I'm going to discuss. I offer and invite you to kill several birds with one stone. So many birds that we even do not know about their presence, but they will be caught. So the molecule we are practicing with is absolutely small. So small that it is almost unpractical. If you go to true molecules of research interest or nanostructures, nanomaterials, you'll recognize that amount of orbitals will be very huge, and we will need a specific tool that will summarize all orbitals into something that human eye can comprehend. Yep. Good. What else? So sensitive.
Space dash space either for
Okay.
I did a like on scratch space.
So, molecular orbitals, their multiple benefits, and I already gave a disclaimer that there is no theorem proving that the following benefits must to be related to real life, but they are. So, if you write energies of occupied and unoccupied, if you just know the energies, it immediately prompts you the three characteristics of material. First, color, which is a band gap. Second, ionization energy, and third, electron affinity. So since those are occupied, if you remove an electron from here, you the energy of this orbital does relate literally to the energy you spent to ionize your molecule, because you go from here to there. So the lower the orbital, the larger energy you need to apply to promote it to the vacuum. So it is ionization. It is not exact ionization. There is a theorem telling about approximations, but for quick assessment of your molecules, it is really helpful. And LUMO energy is electron affinity. It is what is the energy to place a molecule or place an electron to this molecule. So those of you who are on the truly hard chemistry track, which experimental setup allows to measure ionization and affinity? Which characterization techniques you are aware of that deal? So removing electron is oxidizing, placing electron is reducing. So I think Austin, Christian, and Daniel, and of course our strongest chemist, London, may prompt some techniques available at each analytical chemistry lab that measures the energy to oxidize or reduce a molecule in a solution. Hmm? Did you recognize? Do you agree? Please tell it once again. Cyclic voltammetry. So you apply different potentials which enforce electrons either to leave or go to the molecule, and you record when the current maximizes, which means that this process occurs, and it responds to specific value of voltage, which corresponds to scanning through the stuff. There is another technique less popular among true chemists, but it is more for surface science. There is a scanning tunneling microscopy. So, yeah, not TM, STM.
Oh, yeah, that's it.
STM. So these energies can be computed and they can be measured on experiment. So even if we stop our development here, you all become very valuable helpers to any experimental research. those are observables that can be measured and can be predicted by computation. Build molecule, run FAST-FOG, predict observables. Easy way. Okay? So it is one benefit of knowing the energies of orbitals. Second, I wouldn't say benefit, but specifics. If you have a molecule or material with 200 or 1,000 atoms, the number of orbitals will be so dense that it will be very hard for human to read the list of orbitals. Therefore, one needs to introduce a concept of, if instead of orbitals we call them states. Concept, yes, concept of density of states, which means how many states per energy interval, or how many orbitals per energy interval. Delta E. DOS, how many orbitals per energy interval. So in the band gap area, there are no states, and density of states will be 0. Above gap, there will be some states, so it will be above 0. Below also, non-zero density of states. There is a very simple equation. I just do not want to torture your young brains at the end of the day. We will have a chance to cover the equation, but there is a protocol how to convert list of orbitals into this continuous line of density of states. In fact, this script does several actions. It does it? So it does convert the rows into columns. It does convert atomic units into electron volts, and it does create data file that for this continuous density of states. So upon execution of this script, you will have density of states in numerical form already in your directory. If you are a big fan of Microsoft Excel, you can just download this file and make this image. So in a minute, I will go make a circle to see that we are on the same page. But for those of you who are curious, every line in numerical format is discretized, right? So our interval of energies, where we define DOS, is not continuous mathematical line. It's just set of dense discretized points. So it is how many points? This one is width of line width of each state, and this is how many below comma, how many above comma in electron volts. Whoever will select this subject will probably create the same slide, make an arrows, and explain to the rest of the class. So a little break devoted to checking that everyone is on the same page, and then we'll, if you have this printout, you can imagine and guess what will be the next. Yes?
I just have like a theoretical question.
Please.
So the homogeneous states that you have, like, is 5, 5 just kind of a good starting point?
Yes.
Like, what would happen if you increase those states to make a bigger?
So let me.
I guess I can mess around with it.
It will be. It is another idea of a homework to do the density of states of the same molecule with different set of parameters. But for your question.
And I can rephrase it too. Like, is there any limitation to how many like homoorbital gases you can be analyzed?
So you have energy of HOMO and you have energy of LUMA, which is given to you by Hartree and Fock for given mode. You don't change them. And there are much more orbitals here and there. And then your density of states will be some image like this, right?
It's making a lot more sense now.
Okay.
Well, trust me, the further we go into this class, the more that those graphs that we see make more sense.
Exactly. Yes, you'll see it again and again, and you will plot them again and again.
Okay.
So -5 tells that you are not looking for infinite low energy states. You just cut by going -5 to here, 5 to there, and box it this way. So you focus on the gap plus -5.
Would we expect to see like two kind of like separate curves if we did go out to, as it approaches infinity to like both sides, where it kind of like comes back down, and there's zero towards states?
It is very system specific. Experts or people who works with density of states a lot can look on the density of states and tell which system it belongs to. But they have, as you may recall from PChem, there are qualitatively different shapes of density of states. Like if it is one-dimensional like carbon nanotube, it will have the Van Hoff singularities. If it is a solid bulk, it will go as a square root of whatever, right?
Yeah.
And it will be wrong to give general features of density of states.
Okay.
There are no. It is for each specific class of systems, features will be different. Okay.
Yeah.
Oh, jeez.
Reduction means that you're reducing the oxidation number, right? Like you're making it more, you're adding electrons, you're making it more dangerous. Okay.
Yeah, you'd be reducing the
Leo goes good. Leo goes good. Lots of electron oxidation, gain electron reduction, or oil rate oxidation.
but this question is moving on.
Yeah, I'm just saying that's, if you want to know, that's what the acronym's for, is to determine that stuff.
Cathode is the positive.
I don't remember the oil rate one is.
Funny because if you're doing standard kinetics, cathode is the positive. If you do the electrolytic cell, that is negative. So don't try to memorize it.
Just downloading the.
You'll have to actually learn it when you think about it.
Oh my goodness.
So everyone got run this script, right? Okay, so everyone except me. It's my time. So I will not brag and lie that I recall all this long syntaxes. I will just do a regular. Yes. And then the name of the file was different. So it was lowercase out. Okay. So it did generate the file that is named same as it was before with letter E up front, right? So if you do more of this E, so here is the dream of Christian. So the energies of orbitals are expressed in electron volts. Well, the third column, see, here is our HOMO and LUMO, minus 0.5, minus almost 0. So here is atomic units, here is in electron volts. So one predicted that it will be minus 14, he was close. Minus 13.78. So number of orbital, and here number of electrons. How many electrons per orbital, because up and down, 2. Right? So, what is density of states? I'll go to other side because I don't want to damage my precious calligraphy. It was sarcastic. So, if here is energy, and here is energies of your specific orbitals. HOMO, LUMO, LUMO plus 1, HOMO minus 1, right? And we want to consolidate this concept of orbitals into continuous line. So we connect each individual orbital with a shape, with a profile, just as a instead of line, we will draw something like Gaussian or Lorentzian shape, and then add all of these functions together. When you add functions together, it will be something like one big continuous line. Right? And if you do have handful of orbitals, it is silly. It doesn't help you. You can analyze everything just looking at numbers. Like if there are 2, 3, 5D orbitals. Okay, human can analyze it. But if there are 5,000 orbitals, it's not possible. But continuous line will have the same format all the time, and you can assess general features of material just looking on this part. The equation that connects the lines, shapes, and overall is simple. You just skip writing it so that no one feels too tired. Whew. What is my next command? If I forget what to do, I just do list and look what files are available. So this DOS, we can guess that it stands for density of states, right? More DOS. So you do see that the first and last columns progresses forward with very small steps, right? The absolute value support that most likely those are energies and electron volts. And you can also notice that they are offset by the same number. So you will see later that sometimes one can frivolously shift all energies to set 0 as a halfway between HOMO and LUMO. But sometimes, if we need electrochemistry and affinity, we shouldn't do it, right? Because it will screw up everything. But if you're looking only in optical properties, we can just shift so that we do not disturb by higher or lower affinity materials. So if we just focus our glance onto the area between HOMO and LUMO. So if you pull this file into Excel and select 2 columns and yes? No, download. You know how to download by SCP. And we do not, SCP is a torture because you need to type. But yes, you just go to, well, right now it may need to. I see. Well, it will take maybe time for it to reconnect, but here there will be mouse operated list of files and you can download them.
Yes, I would try that, but it doesn't immediately go to Excel, so is there a different version you have to do?
You can change the extension of the file, or in Excel, you can do import. Import raw data or import plain text file.
Yeah,
Yeah, but copy and paste will work if it is a small number. If there will be thousands of orbitals, you'll get tired soon enough. Maybe sooner than before you catch all.
Control A and highlight everything.
Okay, you know how to survive. So basically, it is another possibility to stop right now. So like, here's your numeric file, go to Excel and plot it, right? But it's not pleasant. We need to make life as easy as possible. There are additional scripts, there are additional codes right on the HPC that will help us to make this plot. So let me invite you to type the following word. GNU plot. And then, so this is a tool for plotting and drawing for those who developed hate towards Microsoft products. There are several tools that do the same, like converting data into graphs. Maybe one of the favorite is Origin, which you can use instead of Excel, right? But it is commercial. And GNUplot is for free for the last 30 years. So if you are in a healthy X11 forwarding connection, graphical connection, there should appear something like this on the screen. So name of the file that starts with DOS, then U stands for using first and second column, WL for width lines. I'm going to make circle and see around and see if we are on the same page.
That's all.
That's like your presentation. Okay. Oh, for these your success.
So for try.
Okay. Okay, let me.
Yes.
So one is file.
Yeah, that mine did that the same way.
That's just because we use the one more.
Are you taking your name of file, so you're copying what I
Okay, that's true.
Well, that was originally what it was.
Right.
So I just tried it with. Yeah.
But if you look
No,
here, you
yeah.
can
If you
see
look at
it's-
that, that's much better.
And these are different optical forms.
And then it
Which I showed you. This is one of them. So this is like intensive light at 818 millimeters. This is actually just the one millimeter. It doesn't want to go this way. That's all I got there. And then I started actually trying to go on. So
Ah.
it was like a good size.
It's pretty cool.
You went all over from that.
Yeah.
Okay, yeah, that's it. The finished.
What's the ball?
I want to know how complicated it was. I'm not interested in this or that phenomena in the spectrum or this or that element. I want to know this dots. The rest are in
I had no clue either, Austin, but I got it to work after doing one for this.
How far is your success?
I got it. Yeah.
No,
I had no doubts.
I have a question. Though.
Yes.
So, for titanium material, which would be a better functional to use?
Well, that's what I
PDB
did.
one.
I hit Control C. Remember, I was like, oh, I
There's-
Hybrids are with
typo with my spot.
HC.
Which, you know, is very
But-
likely.
If you are looking for small molecules, just use couple clusters.
Okay, what about larger ones?
It is more, well, we shouldn't put it on the record, but it is more art than science to establish correlation between precise properties and choice of functionals.
You need experimental to kind of guide you a little bit.
More and more people with years stop believing in DFT in general. Hybrid functionals, HSC, have good reputation. But you couldn't catch my word and then later tell, he instructed me to do this functional and expect correct band gap. So what do you do next? Are we happy? Is it sufficient? How do you?
Okay, so how is yours different from ours?
The structures might have been a little different.
Yes, yes. The structure is very sensitive to geometry. Change of 1% of bond length may screw up or improve the energies by like electron volt.
Okay.
So right now we are not analyzing material to the full extent. We just learning protocol. Okay, so if you need to go into big work immediately and publish papers, you probably can cache screen, cut this image, and put it there. right? Or go to your favorite Excel or Origin. But there are opportunities to do editing of images right in the GNU plot. So there are some simple things that can be helpful. For example, one can change line width. One can create high-resolution PDF files, not the screen catch, but PDF. One can put access, change fonts, and some of you who like practicing and learning new things on Linux may explore 300 commands of GNU plot. For example, there should be opportunity to change and after typing, nothing changes. But if you tell replot, it should implement your changes, like you put your access. And there is a replacement of catching the screen. So if you're exposed to programming, you know that you can save information to files, you can funnel information to standard output, and you can encode files in different formats. So this graphical information, right now, it goes to standard output onto this graphical information on the screen. But you can funnel it immediately into PDF file or into some other finer styles that we will cover later. So set terminal post script, and you can tell change size of font, set out, and then give file name, for example, dos.ps. PS because it is obsolete predecessor of PDF. And then you type replot. After I type replot, the graphical image disappear, and instead on the directory on disk there will be new file in this format. No? It didn't disappear? Okay. And now I can exit the GNU plot by quit and look for the files. So there did appear a file dos.ps. Which I can convert to PDF by this command. By now, there on the disk space, you have the same image in the form of high-resolution PDF. This, why should we, like some of you may think, why should I spend time if there are like 4 commands? Can I better do it on Origin or Excel? The difference is that here you can do everything, you can put everything in script. So you do it with one click or with, and you can, by arrow up, you can repeat similar commands again and again and generate tons of graphical information quickly. And then download it and put immediately into the whatever paper. So I don't care. You use your own style of plotting, but let me offer this opportunity. So let me go around and see if you experience any error messages, and then I will return back and if everything goes seamless, you can download this .pdf file and see how it looks on your screen. Let's so just set
Yeah.
So,
Yeah. Yeah. That.
in
Yeah. Is it that something? It doesn't kick me out once. Oh. I don't know. Obviously, maybe this. Oh, you're on. Yeah. Yeah. That's a good question.